It isn't a ghost of the machine, it's something far more unsettling. A trillion words, a vast, silent library of human thought, emotion, and history distilled into a mathematical void. When you type a prompt into a chat box, you aren't talking to a person. You aren't even talking to a simple program. You're interacting with a mathematical ghost, a shadow cast by the collective consciousness of humanity. But how does it know what to say? How does a machine turn cold numbers into warm, poetic prose? To find the answer, we have to go inside. We have to follow the trail of the data as it undergoes a terrifying transformation. The journey begins the moment you hit enter. Your words are not read as language by the machine, they are hunted. First, the system performs an act of dissection, tokenization. It shreds your sentences into tokens. These are fragments, words, syllables, or even single characters. To the computer, these aren't letters, they are coordinates. They are pieces of a puzzle that must be mapped before they can be understood. Next comes the mapping, the embedding. Every token is assigned a location in a high-dimensional space. In this mathematical realm, king and queen sit side by side. Apple and pear are neighbors. The machine doesn't know what an apple is. It only knows that in the history of human writing, the word apple often appears near fruit, crunchy, and red. But words have a position. In a sentence, the man bit the dog is very different from the dog bit the man. To solve this, the machine adds positional embeddings, a timestamp for every word, ensuring the sequence remains intact. Now we reach the heart of the mystery, the transformer. This is where the magic happens. It's called the self-attention mechanism. Imagine a sentence as a crowd of people. When the machine looks at one word, it must decide which other words in the room matter most to its meaning. If you say the bank was flooded, the machine looks at the word flooded. It ignores the possibility of a money bank. It focuses on the water. The attention mechanism weighs these relationships in real time. It isn't just doing this once. It does it hundreds of times across dozens of heads. Each head looks for something different: grammar, sentiment, tense, and logic. They are all trying to build a complete picture of the intent behind your words. This happens inside the transformer block, or repetitive cycle where the data is squeezed, filtered, and refined through layers of neural networks. With every layer it passes through, the meaning becomes more abstract. The raw text evaporates, leaving behind only pure context. By the time it reaches the final layers, the machine isn't looking at words anymore. It is navigating a sea of probabilities. But how does it decide what to say next? The machine produces logits, raw scores, for every possible word in its entire vocabulary. Then comes the softmax function. It turns those scores into probabilities. One word might have a 90% chance, another a 5%. But here is the twist. If the machine always chose the highest percentage, it would be repetitive. It would be boring. To create creativity, it uses sampling. It rolls the dice. It takes a calculated risk on the less likely paths to produce something that feels human. This is the autoregressive loop. The machine predicts one word, then it adds that word to your original prompt. Then it feeds that new sequence back into itself. It predicts the next word, and then the next. It is building a bridge as it walks across it. Each word is a step forward into a future it hasn't seen yet. But there is a shadow hanging over this technology, a question that keeps researchers awake at night. Is it thinking, or is it just a stochastic parrot? Some argue the machine has no soul, no intent. It is simply calculating the most likely next piece of information based on a massive statistical map. Others point to emergent reasoning. They argue that when you build a system complex enough, new behaviors begin to appear, behaviors that weren't programmed but emerge from the sheer scale of the data. We call this the black box problem. We design the architecture. We know how the gears turn. But we cannot always explain why a specific weight in a neural network led to a brilliant insight or a hallucination. The machine can lie. It can invent facts with total confidence. Why? Because it doesn't care about truth. It only cares about the probability of the next word. In the quest for perfection, we've created something that mimics our intelligence so well that we can no longer tell the difference. The next frontier isn't just about better words, it's about reasoning. New models are moving toward chain of thought processing, where the machine is forced to think through steps before it speaks. They are moving from retrieval to logic, from answering questions to solving problems. And eventually, these models won't just stay in chat boxes. They will become agents. They will browse the web. They will use tools. They will execute multi-step goals independently of our constant input. The machine is no longer just a mirror of our words. It is becoming a collaborator in our world. But as the line between human thought and machine calculation blurs, who is really in control of the narrative?